Hello, I'm Casey, and I hope you've enjoyed the SINCON conference the past 2 days. Now, last but not least, let us welcome Nishant and Jeswin, who will be teaching us about writing Wireshark plugins for security analysis.
Hello guys, welcome to the event. This is Writing Wireshark Plugins for Security Analysis workshop. So before moving to the main content, a little bit introduction. My name is Nishant. I work for Pentester Academy. Before working with them, I was working for another company which used to create access points for enterprises and the Wi-Fi intrusion prevention system. I have a master's degree in information security, and for a couple of years now, I am training and presenting my research at different conferences worldwide. Jeswin Mathai is the person who has contributed a lot to this workshop, and he's my co-trainer also. This time it's virtual, so he was mainly dealing with the support and all the things, but he had a very good contribution to this. He is a security researcher at Pentester Academy, and with me and with the team for past couple of years, he has been publishing research. He is training people across the globe. Some cool logos for the conferences where we have been. So pentesteracademy.com is a on-demand video course website. So pentesteracademy.com is the main website on which we have different courses related to security. And then we also operate attackdefense.com, which is a browser-based cloud lab. So the main USP of the lab is that you don't need any VPN, you don't need any plugin, just a web browser is enough. So now coming to the workshop outline. First, we are going to talk about the basics of Wireshark plugins, what kind of plugins are there, and then we will also take a hello world example of different kind of plugins. And then we will talk about the heuristics dissector, and then we will go ahead and we will also see how plugins can be developed for conventional and newer protocols. So what is the motivation for creating these Wireshark plugins? So these Wireshark plugins are actually a very specialized, specific, compact code that is to perform a specific task. So now Wireshark is a very popular tool. It's been around for quite some time now. And the main objective of this tool, or the main work that people do with this, is the microanalysis. So suppose you are working on something and now you want to debug the protocol, you want to see what is happening with the packets, what kind of packets are going and coming, right? What kind of values are there. So you can do that with Wireshark. You can take the trace. You can take the trace, you can look into the packets and what's happening, right? But what if you want to do macro analysis with it? So when we see macro analysis, it means you want to come to some conclusion, or you want to create a summary after looking at multiple packets. So that's the point here, because when you can do that, you can detect attacks by correlation, you can see a pattern, and you can say that this kind of activity is happening, right? So we will take an example of all of this, later in the slides. Second thing, suppose you're working for some company, or you are working on your own project which has a custom or proprietary protocol, right? So in that case, it is very likely that Wireshark will not be able to understand what the packet is, and you will only see the chunk of data, right? So now if you're doing it day in, day out, it makes sense to write a plugin which will actually understand that. And it will be, the structure is known to you, right? Because it is your company's protocol or your own custom protocol. So once you do that, you don't have to deal with all the hacks and those values again and again, right? Third one, as I already mentioned, when you have power of macro analysis, you can detect attacks, you can detect a lot of things. And why Wireshark? Because Wireshark is everywhere. It is well maintained. It is free. It is available on all platforms. It is available on OS X. It is available on Linux and Windows as well. So you can do it on any platform without having a need to move to Linux or something. Now, how to create these Wireshark plugins? So you have two options. First one is to use Lua scripts. So Lua is this language which is high level, and it is more like English. So it is more easier for new people to grasp. Then the other option is to use C and C++. Now we know that C and C++, it is also a high level language, but it is not very user friendly because a lot of things you have to do on your own. Even if you're using libraries, it is better if you have done this before, right? For new people, it is not that easy. So what we did, we actually went with Lua. Why? It's obvious, right? It is user friendly. And the second thing, there is no compilation needed in this case. So you can just write the Lua script, and then you can put the code in the plugins directory, and it will run out of the box. So if you go with C or C++, you know the drill, right? You will write the code, you will compile it, you will put it, where it is supposed to be. And if something is wrong, or if you want to enhance it or modify it, you have to repeat the cycle. So choosing Lua will actually reduce the work, at least now, when you are learning about it. So now how to locate the plugins folders, right? Where the plugins are. So that's very easy. You open your Wireshark, you go to help, and from there you go to about Wireshark, and then it will show you the folders, and you can go with those folders then. So I will show you now. I'm using Windows, but you can use Ubuntu, you can use any other Linux, or you can use Kali Linux if you want, or similarly for OS X as well. So this is the Wireshark. Now you go to help, and in help you go to about Wireshark, and you can see that it's a 3.0.6, and here you can observe that we have different folders. So this is the personal Lua plugin folder, right? So suppose if I only want to do this for me, for my user, I'll use this. If I want to do it globally, then I'll use this one. And if you click on it, it will open it up. So, but don't put these in both places, right? Because what will happen then? Also, it's very important to understand this one is not for Lua, okay? So this one is for Lua. So also it is very important to understand that don't put these in both places, right? Otherwise you will see duplicates. So that's not good. So if you have the binary ones, if you use C, these are the locations. If you're using Lua, then these are the locations. So I have already opened this one. So let's see. Currently it is blank. So there you go, totally blank, nothing is there. So we will now put something here, and then we will see how all of this is working. So now going back to slides. So if we talk about the plugin types, you can broadly categorize these into two categories. First is the dissector, and the other one is the listener or tap. So in dissector, you will have again different subcategories. You will have the chain dissector, the post dissector, and the heuristics dissectors. So let's see what a dissector is. So suppose whenever you are getting a packet in Wireshark and you are seeing this very beautiful tree created, right? So what I'm talking about, I'll just open one PCAP and I'll show you what I actually meant. So here you can see that all of DNS traffic is here, and what you can, so here you can see that all of DNS packets are there, and if you select any one of these, you will be able to see all the layers. So you can see that the Ethernet is the first one, and then it is the IP layer, and then obviously the UDP, and in the end the DNS one is there, right? So this is the tree that I'm talking about, right? So easy it is to to navigate it, to find the information that you need. All of this is here. So now how this tree is created. So what happens when this packet will be sent to Wireshark, it will go through a number of dissectors which will process it, and then it will give it back. So just remember this part: the Ethernet, the IP, the UDP, and the DNS. So you can see it's kind of we are moving up the network model, right? You have your application layer, you have your transport layer, then you have your networking layer, and then you also have your MAC layer, right? So if we go back to the slides, what happens when, so packet, what is it is, right? Packet is nothing but a collection of bits, right? At the end of the day, it's just a collection of bits that represents something. So when I say something, half of it or most or some of it is actually related to the protocol that will be used to transmit, to understand it, and then there is the real data, right? So what we do when the first time packet will be given to Wireshark, Wireshark will be passing it to the first dissector in the chain. So in this case, the first dissector is Ethernet. If you have a radio tap also on that, then the first will be the radio tap. And Wireshark has conditions which are defined in these dissectors, which help Wireshark to choose which dissector to send it, right? So if it is a Wi-Fi packet, it will go accordingly to another dissector. If it is a LAN packet, then it will be accepted by some other dissector, right? So what will happen now in this case, when an Ethernet packet will be passed to dissector 1, that is Ethernet, so this dissector will parse the header and all those components of header for the Ethernet part. And then rest data, which is the payload of Ethernet packet or frame, will be passed to the next dissector in the chain. So here we can see the next one is IP, right? So IP dissector will again do the same thing. It will parse its own header, and then it will pass the remaining one to the next one, that is TCP or UDP, depending on the protocol. And then similarly, it will be passed on to the application layer. And then if you have something custom, so suppose, for example, if you have built something which is running inside the HTTP part, right? So you're sending some kind of signaling messages or something using HTTP, then you have to write your own custom plugin, because Wireshark will not be able to decode it after HTTP. It will show you all the fields and everything passed properly till HTTP. But if you want beyond that, then you have to put a custom dissector at the end. Similarly, if you are putting it, in some cases it is possible that you are using some kind of custom, encapsulation. So in that case, you will put your dissector in the chain, and similarly, you can put it in the end. Depends. Now, what is a listener? Because we are going to listener now. So dissector is when you want to parse the packet and you also want to show whatever you have seen and interpreted as part of the tree. So that's for the dissector, right? Now for listener, you don't want to show anything in as part of tree, but you want to save this information, and then you want to go over packet by packet on multiple packets, and then whatever summary or the statistics that you're getting from there, you want to show them in collective manner. So that's the microanalysis or summary part, right? As we were talking before. So how to write a hello world, program for a Wireshark listener? So it will be a simple hello world program. We will just talk about the skeleton code, and we will just do some simple things, so it becomes more clear to you. And then for more complex things, we are providing you with the code, so you can go back and you can try out with code as well. I'll also do a code walkthrough for you. So the file name that we will provide is the hello world listener.lua. So first line is to check if the GUI is enabled. So it is done because T-Shark is also there with Wireshark. So those people who don't know what T-Shark is a CLI based cousin of Wireshark. So first of all, we are checking because in this one and also in the dissector one, we want to show this output. For now, we want to show this output on GUI. So if GUI is not there, then there's no real reason to run it, right? If it is running in CLI or something. So first check is if the GUI is enabled, then it will run. Otherwise, it will go back, it will exit. After that, we created one function. We named it dialog menu. And in that, we have created a window. So this window will have title hello world, right? So you can see clearly this function here will create the window, and this is the title that we are putting in. And then we are setting this text in the body of the window, which is again hello world, but here I have 3 exclamation marks, here I have 1, right? And once you write this function, you now want to register it with the Wireshark UI, right? So what we have done, we have registered it with tools menu. So it will appear as hello world in the menu. You click on it, it will open up a window, and the title of the window will be hello world, 1 exclamation, and the content will be hello world and 3 signs of exclamation. So this is how it will look, hello world. And if you click on it, this is how it is going to show. So it is clear, right? So this is the title part, and this is the content. Now, obviously, it's a hello world program, and that's why we are actually printing hello world. Otherwise, there's no real reason or benefit of printing hello world. Obviously, what we will do in real example when we do this for realistic protocols to find some meaningful information, we will go over the packets and we will try to find the statistics and all, and then we will show those. So that will make more sense. But before doing that, let's also take a look at hello world dissector. So what we are going to do now is we are going to add a dummy hello world to all the packets in the protocol tree. And the file name is hello world dissector.lua. So first, in this case, I will define the variables and the field. So first of all, our protocol name is the hello world. It will appear, with this name. Obviously, this is the name that we will use internally. And then we are defining the fields for it. And you can also see the hierarchy, the name of the protocol. And also here, we have defined the name of the field as hello world, right? You can see the variable name here, hello world. In this, we have defined this specific field. This is the hierarchy to apply filters and all. And again, the name of the field will be hello world. Now you have defined the protocol, you have defined the field, you have to register the field in the protocol. So we take world.field, where world is your protocol object. And you take your field object and you define it like this. So now you have registered your fields to the protocol. After that, we will write a function for the dissector. Now this is from the standard. So you have to pass. So when you define this, it will add in the line in the chain, and Wireshark will then send it the buffer, the packet info, and the tree. the current state of the tree. So now first what we are doing here is we are finding the packet length from the buffer, and then we are adding one element to the tree that is passed to us, and we are adding the hello world to it. So this is the value, and this is the value. So after this, we need to register it. So in this example, we are not really using any conditions because it's a hello dissector. So we have defined it like this. So what it will do, it will attach a new part of tree or a component of tree, or you can say one stage of tree, to all the packets, which will say hello world. So when you run it, this is before you enable this plugin, and this is after enabling the plugin. So what you can observe here is it is everywhere. If you apply filter using this field here, it will look like this. If you apply the filter using the second part, that's the content field, right? Then it will look like this. So you can observe that it is on all the packets here. So these were the hello world plugins that we had. So now what we are going to do, before moving to the next part, we are going to move these to plugins folder and see if if it really works. So here are those two files. I'm copying these. This is the destination. So I'll paste it. After that, I already have a Wireshark opened like this. Now, because the Wireshark is already running, right? So there are two options you have. First is to stop it and start it again, to close it and start it again. Obviously, that will load the plugins. The second one, you also have one more option. You can go to Analyze, and then from here, you can click this part, Reload Lua Plugins. And once you do that, and you go here, you'll see that the option for the listener or the tab is now here. You click on it, and there you go. You have Hello World written here with title of Hello World. Similarly, if you check any packet in this PCAP, you will see this field here, which is added by our Hello World dissector. Now, I was telling you that you can pretty much go ahead and also modify them. So I was telling you that you can also modify them in place, and the changes will be available. So let's do that. So let's open our listener. Here is the listener. It says hello world as of now, right? So let me change it. There you go. I have changed the content. Also, let's change it to buy. And let's also change this one to buy, right? So if I save it, now we will go back to Wireshark. So currently it's hello world. Now let's go here, reload to our plugins, and you will see that now it has changed to buy world. So this is what the convenience is, right? You can directly make the change, and then you can just reload it and it will work. No compilation, nothing doing. So let's move back to slides now. So now let's understand what a heuristics dissector is. So sometimes, or actually for most of the protocols, if you haven't enabled the heuristics of Wireshark, uh, for most of the protocols, it actually uses its port number to find if the packet belongs to that specific protocol. Now, problem with that is if you change the port number, it will not know if the packet belongs to that protocol or not. So to handle all of that, you bring in the heuristics dissector. So heuristics are properties and things that we know about the protocol or the protocol packets, and we can use those to then locate these packets, right? So let's see an example of this. So we are going to take an example of a DNS dissector, and it is taken from Wireshark's own website. It's not created by us. And what will happen, so this is the flow, right? This is the example flow. So suppose till TCP, if the packet is recognized and is dissected, but after that, if no one is understanding it, then it will be passed to the heuristics dissector, and then heuristics dissector will run on it. So this is the example, and we also have a live file for this. We will see that. So in this case, it's the DNS traffic. You can see the content, but the destination port, instead of using your standard 53, it has changed its port to 8089, and due to that, Wireshark is able to understand till the transport layer, that's UDP, but it's not able to understand beyond that. So that's where your heuristics dissector can come in. Here you can see it's telling you that the heuristics dissector is used because no other plugin was able to understand what it is. So my DNS was the name of that heuristics dissector, and it had all the structure of DNS packet. So what was the heuristics in this case? What were the heuristics in this case? So if we take a look on this, first thing is this function which will handle the TV buff and the packet info and the route from Wireshark. It will print that this dissector DNS is called, and then here this is the first one. It is checking if the remaining length of passed buffer is greater than DNS header length. Because if it is a DNS packet, this condition needs to be true, right? It cannot have length less than DNS header, because your packet should have the header, then the payload, right? If it is less than that, then obviously it is not a DNS packet. The second factor they have taken is they know that at this specific location, the opcode has to be one of these. So, it can be 0, 1, 2, 4, 5, but not 3. Similarly, the third factor is that the R code, which has this location, needs to be from this range. And then, verify the number of questions and answers. That should be reasonable. It should not be very high because, it's a DNS packet. If it is a real DNS packet, it will be in this reasonable range. And then, you register the function. And here, what you can observe is, because it's a heuristics dissector, right? So the way it is registered, you actually mention the protocol, before it. If no protocol after this protocol that is mentioned is able to understand this packet, then it will be passed to the heuristics dissector. So that's how it works. So let's see heuristics dissector in action. So this is the file. Let's copy it. We are going to delete the hello world dissectors now. Let's paste the heuristics dissector. And we also need to open the corresponding PCAP. So let's do that. Or actually, let's remove this too for the time being, so that we can see how it looks before and after, right? So let's open the PCAP. So this is the PCAP in this case. And what you can observe here is, this is the data. If you take it a little bit like this, you will see that the domain name is there, right? So this is actually a DNS packet, and we know because the destination port we already know, we already talked about it. And then if you don't know about that, by seeing this specific part, right, you can actually get suspicion. And you can also see that there is a reply which should also contain this name and then the IP, right? So we can observe that Wireshark is currently not able to understand what it is, and obviously we don't have any tools. And again, just to make it clear, the dissector will not show up here, by the way. So let's go back to the folder. Now let's paste the dissector here. It is here now. And now let's reload it. Go to enabled protocols, because it's a new protocol, right? So you have to look for my DNS. And we are in the M region. And here it is, right? It's already enabled. So for some reason it is not working. Let's close the Wireshark and start it again. So here we can observe that this is the DNS packet, and we can also see that it's not being interpreted as the DNS packet or the my DNS packet in this case. That's because the heuristics need to be enabled. So that you can do, you can go to edit, you can go to preferences, and here from protocols, just type the name. So in this case, the my DNS's name. So there you go, my DNS. And here you have to enable the heuristics. You do that, you click OK, and it will work. You can observe heuristics dissector used, my DNS, and now you are seeing the DNS one. So this is how the heuristics dissectors they work, right? So when so if suppose you are searching for something which can be a HTTP tunnel, but it's not really running on HTTP tunnel. So this might also be one way of doing it. It will obviously work for the DNS tunnels if they are not using on the standard ports. But for HTTP, you can check. Going back to the slides. So now, similarly, using the same concepts, we have created multiple plugins for Wi-Fi. So I'll walk you through those. So this is the one for overview. So suppose you want to see from security perspective that which SSID or BSSID in a PCAP or in the live traffic feed have weak security. So for example, here also you can observe that serial number 2, 3, 6, 8, and 9 and 12 have WPS enabled. That's a very, very, very bad thing from security angle. So you can do that. Now using the same analysis logic, you can actually also see if someone is performing the Wi-Fi beacon flood, so in which he is sending random SSIDs with different BSSIDs, or if he is sending multiple BSSIDs but using the same SSIDs, right? So it becomes very easy for you to use it to find the problem using Wireshark plugins. Similarly, if you want to see if the deauthentication attack is being done, you can see stats about it. You can see how many packets are being sent per second. You can also see if it is a broadcast deauth or if it is a unicast one. Similarly, checking the WPA cracking possibility. So now you can go ahead. You have the PCAPs, you have the plugins. I'll show you how to use them, and you can try these out. So you go here and just go to the plugins part and just copy all the plugins from here. This is the plugins folder. Paste everything here, so we don't have to do it again and again. Now we can go back to the PCAP folder. And let's open one of the PCAPs here. So let's open the deauthentication flood ones. So it's opened. It's a large PCAP, so it's taking a little bit more time. So it will also show you the benefit of this, right? You can observe that it's around 184,000 packets, not the precise number, but the cutoff. And from here, you can observe that you have different options. So I'll go for the Wi-Fi one. If I do overview, and as you can observe, these tables, we have created these in a very basic manner. So these are just the characters which are forming the lines and the borders. So you can observe that, all of these are here. For some of these, the WPS is enabled. You can also do a search on it if you like to. So for example, I want to see the PA_net. Do OK, and it will filter. Similarly, you can use all the other plugins like this to see the deauthentication flood. You can observe that this guy is doing deauthentication on all of these, right? And then there is another one. Similarly, all the other tools, all the other protocols and everything, we leave to you. You can try these out. Now, let's move back to the slides. So now we will take a look at a plugin which is created for a conventional protocol, and we will see how it is working, why it was needed. So we will talk about the SIP. SIP is Session Initiation Protocol. It's used to do your IP telephony. So if you want to do VoIP, SIP plus RTP is one of the widely used protocols. So suppose you have a lot of traffic for SIP and RTP. You want to see what is happening. You want to create a summary out of it. And you also want a dissector to show you in clear the authentication hash that is used by these clients for authentication, right? So let's go back to the Wireshark. So this is the SIP capture. Open the SIP capture. So you can observe that the hello world is everywhere, right? So let's get rid of this. So I have deleted those plugins, the basic plugins, the Hello World Dissector, the Hello World Listener, and all the other ones. And now we only have the SIP ones that we want to consider along with the other protocol ones. So here, if we go to the SIP extensions, if you click on it, it will show you these are the unique extensions or users or numbers that are used to make the calls or tried for the calls or registered with the machine. Now the second one that we have here. So what happens first time this client is trying to register to this server, it is getting unauthorized because it was not sending authentication hash. So now in next message packet, you will see the authentication hash. So this one is our custom SIP dissector, and we have used it to carve out this specific part. If you don't do that, you have to open it up, and then somewhere here you will be able to find the authentication response. See this, right? The digest. So we are taking it and we are putting it clear here, so it is easily viewable. So again, this is a sample. Similarly, for the memcache ones, you have to open the memcache file for that. Let me do that. So here is the memcache one, and memcache has its own dissector as well. But let's try to see which items it is getting, the key value pairs. So if you go here and if you click here, you will see that the key value for all the interactions is here, and that is in a very easy and summarized form. So now let's take a look at the code of these two. So let's start with the SIP listener part. You will see that the skeleton code is not changing a lot. We are just adding some things to it, and it just works. So first line, now it is just a UI check. If the GUI is enabled, then it will run. If it is not enabled, it will exit. So from here, we are taking this value. We can take this value because the SIP protocol is already parsing it. If it was not parsing it, then we have to parse it, but that's not the case. So we can take the user from here, and what we are doing here is we are creating a table to store unique usernames, because we want all the unique users or extensions which are used to make a call or to register with the server. So we did that here. Now we are filtering the frames with this specific filter, because these are the only packets that will contain this information. And when you open a new PCAP, obviously you don't want to retain all of this, right? If you haven't closed your Wireshark and if you're opening a new PCAP, obviously this should change. So that's what we are doing here. We are resetting the tab, so this value is again empty. And now this is the main function which is taking information, the packet info and the TB buff, and from there it is getting the username. So user is defined here, right? So this means this. So from this field, it is taking the username in string format, and if it is not already there, it is storing it. Then we have the dialog menu, which will be used to show the information. So this one here is actually getting the information, and this one will be displaying it. So when you will click on this window, a window with SIP extensions will open, as we already saw, and it will have unique SIP extension of the users, and it will append all the users in form of a list. So we are printing all of the information, and then this part you already know. This is to register this specific function to your tools menu. And we have already seen this in action, right? Similarly, moving to the SIP auth digest dissector, you can observe that we have defined a protocol that is SIP auth digest. Then we are defining a field in it for the digest response. And then, this response digest field, we are taking it, this information here. It is coming from an already parsed field by the SIP, right? So this part, you can see SIP auth digest response, and this is the one that we are creating, okay? So after you have your field, you have your protocol, you register the fields with the protocols, and then you have your function, the dissector function. If it is the digest that is being taken from this part here, if it is nil, then it will not run. If it is not nil, then it will run, and it will take this information, add it to the tree, and then we will be able to see this tree. And then you will register this protocol. So that's how the dissector is happening. And then the last one, the memcache listener plugin. In this one, again, you can see that we have already passed information. So we just want to take it and we want to show it in a summary view. So first of all, we are creating this listener here, and it is taking memcache value. And then, you are taking these objects from these fields which are already passed, and you are storing it in this store. And once you have all of these, this one right? This is to reset, and this is the main function which will fill the information. So you are going over the packets, and where key and value are not nil, you are taking them, you are converting them into strings, and you are storing it in the store. And then the display part, you are creating a text field, the text window with a title, that is this, and then you are printing this, this line here, that these are the memcached key value pairs, and then you will take each key value and you will print it. And this one again is to register this function with the tools menu. So with this, we have covered the memcached as well as the SIP. So memcached, for those people who don't know, memcache is a RAM-based caching solution, which is used a lot by a lot of industries, a lot of people, and mainly the way it works, it has keys and values stored in the RAM. Whenever you want to store something, you provide this pair. It is saved in the RAM, and when you want to get it, you need to know the key, and by sending it the key, you can actually get the value back. And that's precisely what we saw in the plugin. So if you want to download, all of these, you can do that from github.com. We have posted all the code here. If you want to see more specific things to VoIP, it is at this link. So with this, we conclude this workshop. If you have any questions, this is my email address. You reach out to me and I'll try to help you out. Again, thanks for watching this video. I hope you learned how to create a new plugin for Wireshark using Lua language. And hopefully we'll see you again next. So with that, thanks again and all the best.